Hello everybody and welcome back to AI Blade, bringing you cutting-edge AI security. In this week's episode, we are going to be taking a look at AI penetration testing with Vul Hunter. For years, CISOs have been fantasizing about truly automated penetration testing, allowing them to quickly find critical bugs in key applications. While this dream isn't fully here yet, Vul Hunter offers an LLM-based code analysis package that promises to find and explain complex, multi-step vulnerabilities. In this article, we'll look at what Vul Hunter is, how it works, and if this tool lives up to its bold claim. To begin with, what is Vul Hunter? Vul Hunter is an LLM-powered static code analysis tool by Protect AI, specializing in uncovering complex Python vulnerabilities. Over a dozen zero-day vulnerabilities have been found in popular GitHub repositories using this tool, showcasing its immediate value for bug bounty hunters. Vul Hunter is free to use of the time of recording and works with Anthropic, OpenAI, or Ollama for the choice of large language model. How does it work? Vul Hunter uses a library called Jedi to parse Python code, starting by analyzing the codebase's user entry point for vulnerabilities. If the LLM finds any potential bugs, it searches other files for references to code objects in a recursive call chain until the full path from user input to server output is mapped out. This call chain allows the tool to ingest all context relevant to a vulnerability without needing to parse the entire codebase, dramatically improving its accuracy and minimizing the required tokens. Vul Hunter analyzes all the context and outputs a final report, proof of concept, and confidence rating for each vulnerability. Getting started. The quickest way to install Vul Hunter is on Linux, and I use some commands from a Hunter blog post to get this up and running. To start with, you need to add repositories to your machine, install pip specifically for Python 3.10, install pipx, and then install the Vul Hunter codebase itself. To run the tool, you need to obtain an API key from your favorite LLM provider. So in this case, I chose OpenAI. Vul Hunter works best on Python applications, so I decided to find a suitable bug bounty target from the Hunter platform. So I chose Apache Airflow as my target based on its web UI and Python architecture. I located the user entry point and ran a command to begin my scan. So Vul Hunter performed a scan and came up with some very interesting findings. It was confident about the existence of a remote code execution vulnerability in the /rendered_templates endpoint, referencing arbitrary Python execution with a POC payload. However, rendered templates is a non-existent endpoint on the target application with an underscore, so I was unable to reproduce the issue. Furthermore, the IDs it references as injection points are not accessible to end users, making this finding a hallucination. It's worth noting that other people have had success using this tool. One of the writers at Hunter was able to find a local file inclusion vulnerability in the GPT academic repository. Next up, limitations. So, first of all, Vul Hunter is susceptible to hallucination. Most findings made by the tool will turn out to be invalid, preventing fully automated vulnerability discovery. Next, the tool is fairly expensive to run. 2 usages cost me $5 of API credit, and across several scans, this cost will quickly add up. Finally, Vul Hunter only works on Python codebases. This makes its application very limited and means codebases in popular languages like Java cannot be scanned as of the time of recording. Final thoughts. Vul Hunter is a valuable tool for penetration testers that leverages the power of LLMs to find vulnerabilities. While it has already had success in certain scenarios, the hallucination rate is still very high, making it another tool for pen testers as opposed to a full replacement. The future of AI pen testing is very exciting. VulnHuntr can easily be adapted to scan codebases in other languages, giving it even more versatility. The more exciting development would be linking it to a web application proxy, allowing it to test payloads on the fly and iteratively craft working exploits. On the other side of the equation, VulnHuntr is open source, meaning threat actors can leverage this to develop new attacks as well. Secure coding will be more important than ever as these tools improve, and I look forward to seeing their advancements for better or worse in the next 5 years. Thank you very much, everybody, for listening. Keep your eyes peeled for another episode in the coming weeks, and I wish you all a fantastic rest of day.